Okay, so this is a bit of an experiment because I've wanted to record something for a while and not really known how to best get into it, so I figured I'd just dive into it. I recently have been going over the documentation for SQLite, and that is really quite good. So let's go here. SQLite. And it's got everything, right? It gives you this nice, simple one-page layout about everything, the flow of it. In fact, it describes it in the order of the flow that it will be going through. And what I thought was actually quite appealing about this layout is you actually have a walkthrough that's talking about the specific files that are here. Now, for a long time, I've wanted to sort of give code tours or code spelunking, code explorations, or whatever you want to call it. Code tours doesn't really make a lot of sense because I don't maintain a lot of the projects I want to poke at. Code spelunking is sort of the right term, but it sort of implies that, like, you know, these are deep, dark caves, but they're really not, right? They're popular projects that are really quite powerful. Now, there's actually a really interesting article I came across on the SQLite project, which is why SQLite doesn't use Git. And apparently it uses this house-built tool called Fossil, which is really interesting. And I kind of wanted to play with this just to download it. In fact, if we quickly go explore, so one of the things I've done for this video is I've made everything 200% scaled up so that viewers at home can sort of see what is going on. Sorry, a bit of a distraction. But the problem is that if anything goes missing, I'm really just going to have to re-record or do future videos or whatever. Apps, search, Parser. I will be building some stuff as well, but that's kind of a side thing. There's several projects I can work on. So, distributed source control management with built-in wiki, hypertext protocol interface and server, tickets database. So that's kind of cool. Instead of having to do this whole fossil access thing, there's a few ways we can get the source code, right, to go look at SQLite. And I was sort of looking at this and I thought, okay, like what I was saying before, it's really interesting that they give you these links to look at these. But one thing I like to do is I like to have the source control, I like to have the source on my local machine because it really helps me to poke at stuff. So I'm very happy taking source code and reading it like a book, right, and going through and sort of jumping around and answering questions and like raising questions, wondering like, oh, okay, this tab result, is that a table result? Oh, well, okay, from SQLite 3 get table, and it's got accumulated output, etc. And I can kind of start jumping around and doing this stuff, but I don't get all the niceties in this web view, right? I can't easily jump around to definitions or use tags or you name it. And I also can't build it. I can't build it and try things and delete stuff and just see if it works. So what I was going to kind of do is, first we're going to get the source code. The second thing that we're going to do is we're going to kind of try to follow what they're talking about here and look at each part. And really, storage engines, databases, etc. I kind of have this weird feeling lately, and it's a very light feeling, so don't raise any pitchforks on me yet. But it's that almost everything kind of is its own operating system in a way. Like, you've got Linux and BSD and all the actual operating systems that are managing some hardware. But databases are sort of similar. They want to have some management over hardware, or even just providing an extra abstraction over the kernel, right, for data access. So it's really kind of interesting because you can get things like this, where you have this whole sort of... This diagram's a little funky because there's no direct flow, but technically this main interface is the user interface, right? The SQL command processor is taking input, and then this guy, the SQL compiler, is working through to generate bytecode. And you don't always have to generate bytecode if you're doing a storage engine, but it's an optimization that SQL engines seem to do and other database engines seem to do, really, because then once you have a virtual machine to process bytecode, it can be faster, right? You can do things like just-in-time compilation, etc., with a virtual machine architecture. Once you have the bytecode, it gets fed into the virtual machine, and the virtual machine is the interface that goes out to these things. So you have B trees, which are the way the data is organized and stored from disk. You have pages, which is table page control. So this is like a page in memory from a kernel. And you have the operating system interface, which is, see, what SQLite is doing is providing its own paging cache rather than the kernel-based one. So it says default page size is 4096 bytes, which is effectively what the kernel is. But what this does is it enables you to have SQLite have an individual page size that is distinct from whatever the kernel page size is. I don't know if that's really something that people optimize a lot, personally. And then there are these utilities and test codes things. And another thing that was really interesting about this document was this discussion of, let's see here. Well, a few things, right? It uses this lemon parser generator. This is one thing that's kind of interesting, and it has a whole discussion of this lemon parser generator. And in fact, it implements the whole thing, and it also mentions how it's different from Yak and Bison. So that already kind of hints that it's a, it's a parser generator, but it uses different input syntax, which is less error prone, it claims. And it's just one C file, so it's very easy to embed. It's a bit of a principle on this project is ease of embedding. The other thing is that there is a printf, a custom printf that handles Unicode. Where did that go? Printf. Here we go. SQLite has its own private implementation of printf with some extensions in printf.c. All right. And then there was actually a third thing. It uses TCL interface as one option. TCL, for those who don't know about it, is a scripting language that was initially kind of around the time that Python and stuff, and Perl and everything were around. It's actually what you'll find in a lot of projects for sort of instrumenting larger programs. Like if we go to Redis is GitHub, and we may do this another day. On Redis's GitHub, you'll see the test directory, right? And I don't know, let's go to tests, unit, scan, select. Let's go. I want something, bit operations, here we go. And you'll see that like there's proc, which is like a function, and then you'll see the actual tests, right? So start server, and then we've got these individual tests after the start server. So it's like bit count returns 0 against non-existing key, R bit count no key, and R is like, I think, running the Redis command bit count with no key. And this is how Redis instruments is testing. We'll see if SQLite is similar. All that this is saying is that there is a way to instrument SQLite with a TCL interface, which is defined in this file. Okay. Part of my ambitions about going through this is really just exploring the internals of like a really well documented well-tested, relatively performant, embedded database, or just database in general. And a lot of people use SQLite as a kind of reference implementation for that purpose. Now, there's certain things that SQLite does not do compared to other databases. I'm hesitant to call them industrial grade because SQLite is used in a lot of things. There are tons of usage on phones, modern phones for SQLite, as well as just literally you name it. It is something that's been used. Although there's a bit of a misnomer here. I've heard a couple people ask me privately, which is like, what's the difference between RocksDB and SQLite? Can't really compare them. RocksDB is intended as a key value store. And although you can think about traditional SQL engines as like key value stores because it's, you know, the simplest database. I love this example. It's actually from Martin Kleppmann's Designing Data-Intensive Applications. And Martin has this example where he's like, the simplest database is, you know, and it's like set. You're gonna have to endure me dealing with my keyboard. I do not use my personal ergodox at work, but I do use it here at home, so it's a bit of like back and forth. And really kind of the core idea of a database is that you have a set key function, which is going to like write something to a file. And then you're going to have something that will right. And the gist behind is that we store stuff and then we query stuff. We write and then we query, except with a SQL database, it's a row-oriented database. And a row-oriented database is row-oriented because a row, which we can think of as just like n array tuples, is like one, John, apples, right? A row is a anonymous n-array tuple whose shape and columns are defined by a schema. And the only upgrade from this sort of key value store thing to an actual database is that we give special precedence to rows. We have things like schema checking. The query language is a relational algebra, so we can ask things like, which we can't ask here. This is just grepping for a key, right? The one thing that we can ask for in a relational database is stuff like select. Let's say that the schema for this table that we're dreaming up is like, here's the primary key, which is an int. Here's the name, which is a string, and here's a comment, which is a string. Right. And so we can say, okay, get every name where comment where name is equal to, excuse me, equal to John. Where is it? There we go. Right. I won't really dig too much into SQL. I'm kind of having the assumption that you know a fair amount. There's tons of material out there for getting up to speed about what SQL is, how it works. you know, the ins and outs of the various different styles of relational algebras, and there is a SQL specification, but there's also a lot of differences based upon how people implement these things. So let's just kill off that example. We will look a little bit at this, but first let's just try to get the source code. I think it would be sort of fun to download the source code via Fossil, right? Now, what we could traditionally do is, there is a really long-standing history in open source of producing tarballs. This is a gun-zipped tarball. It is a SQLite snapshot of 2019, 09, 16, 14, 42. Right, and the way that we read this timestamp is 2019 of September the 16th, and it was at 2:42 p.m. Right. Generally, timestamps should be in UTC, so that's the assumption here, is that this was published at 2:42 p.m. on the 16th of UTC time. This is a pre-release snapshot, and what that means is that this is kind of like what you would find, it's the latest published version of this, right, that was published. But this still may be more up-to-date than this pre-release snapshot. If we want to see a specific version, of the source code, then we can download this. And you'll see that this version, this is giving us the git SHA, or the fossil SHA, excuse me. But this version is 329.0, and if we want to look specifically at SQLite 329.0, we can go look at this, what they call the SQLite amalgamation. It says C source code as an amalgamation, version 329.0. One thing I want to kind of stress is that programming languages are tools. In the end, learning as many programming languages as you can is a great thing, because it really twists and shifts and pushes you to be uncomfortable. And that's how we grow. We grow by getting into situations where we feel really uncomfortable and we're not sure, you know. When you fall into a comfort zone, you kind of hit a plateau. If you're constantly pushing yourself to get into, you know, to extend into new areas, places where you're unsure, you know, what's this particular field of mathematics? How does this particular thing or internal of a program work? The more and more you're ripping lids off, you're going to wind up in places where you don't feel comfortable because you don't understand. That's a classic thing. The other classic thing is that when you another way to grow is obviously have a lot of stressors. And I think that it stresses people out to put themselves into a place where they're trying to learn, trying to get more knowledge, sitting there feeling like, oh, I don't know the answer, but I'm expected to know the answer. But that's not true. None of us really know the answer all the time. You cannot know the answer to everything. So it's this constant push to grow. I'm talking about all of this because I really want to preface any of these videos with the warning that every language is a tool, and like a tool has strengths and weaknesses. In this particular scenario, because SQLite's written in C, we're going to focus on C. But I, for example, write a lot of JavaScript and Rust in my day job. And I write a lot of it in my spare time now, too, because I really like Rust. I've written a lot of Haskell, and I've actually written production Haskell as well. I've written a lot of TypeScript and Python and on. And I'm still curious about, maybe one day we'll do some stuff where we explore COBOL or Fortran or just weird different languages. So that's why we're going to be doing C. I'm not going to try to port it. I'm not going to try to do anything crazy. We're just going to be focusing on C and getting it to build. And we might do some messy things. We might not do some idiomatic stuff. We're going to see how this project is kind of strung together. So let's download this. We've got Fossil here. And one way that I really like to work is I tend to, let's see here. think I can do this. No, I can't. Oof, that's annoying. Okay. So, one way I like to work is just start a Vim session. I'm an unstable Vim user, as somebody joked about the other day on Twitter. And I like to use NeoVim with terminals in it. So what we're going to do is figure out this. My bad. Let's go up here. We're not going to download any of these tarballs. Another day we might download some tarballs and poke around or something, but that's not the point here. We don't need this table C thing open yet. This says that once you do this, I will kind of follow their convention, and I will make a fossils directory. I tend to just have a repos directory, and then we're going to just run this line. Now this is kind of interesting. You clone it into SQLite fossil, and then you make a SQLite directory, and then you go into that. That's interesting. And then you tell it in that SQLite directory to open. Okay, so let's copy that. Oops, this is not what I want. That's from when I was updating my thing. Yeah, let's go back down and there we go. Now there's several different types of version control management out there nowadays, so it's kind of interesting using this one. There's one that's a bit like an older school one called Darks. That's new, called Pijul? I don't know. I don't know if it's like a Spanish style J or not. Pijul? I don't know. This is a bit like Darks. So that's kind of interesting to explore. Some people are really big Mercurial fanatics. There is this discussion that like Mercurial saved the scalability concerns of, Facebook. There are ones like old school ones like SVN, which a lot of projects actually still use. There's like, what's it called? CSV. No, not CSV. It's like, I can't remember. Tons of them. It might be cool one day to actually look at the code for this, and you'll see that instead of like GitHub, they've got this nest.pijul thing, right? I'm just gonna call it Pijul. Yeah. That. So let's go back down and see where we're at. Cool. Admin user RJS, and there's my password. I don't know if that's sensitive to really expose. So I'm gonna go into repos. Yes. I think I can go in there directly. So you'll notice that this machine is quite fresh. I normally have tons and tons of things inside of here, but this is a pretty beefy little box I've built. It is a 16-core i9. Let's see here. With about 64 gigs, 62.9 it was recording there. Okay. And so on idle, you can see some of the stuff that's running is like, here's the screen recording, here's, this is funny. This is Xorg doing its thing. Here's Pulse Audio and GNOME Shell, and Kitty is what I use for my terminal. So what we're going to do is the next step, which is we're going to create that SQLite directory. And then there's some fossil command here we're gonna run. And that seems to check it all out. So that's pretty cool. And there we are. The classic incantation for C stuff is generally, this is the autoconf incantation. The gist behind this is you take a script called configure. You'll notice that guy's here. I don't know why I was pointing at the screen. You're not going to see that. And you say configure, and then you say make, and you say make install. And the gist behind that flow is the configure runs all this auto configuration stuff, which figures out all the details of your system, what's going on over here, what libraries do you have available, etc. And it fills in a bunch of files, make files. And then you run make to actually make all the primary core top level stuff. And then you say make install to actually copy the generated artifact or binary or whatever into some place. And usually that place is designated by a prefix environment variable. Okay? So what we're going to do is we're going to say, I don't know why GNOME Shell sometimes does that weird notification about Kitty. But yeah, you'll see configure make here. And then you can run update to get to the latest version. There's also this UI thing. So use trunk for version to get the latest trunk version of SQLite, or use a prefix for cryptographic hash name, or the name of some branch or tag. For more suggestions on what names can be used for version, use the fossil UI command. So, oops, my bad. This is interesting. So this is giving a local server to show us how things have changed. And it's doing this so that we can, it's doing this kind of like Git has one called Git TK, which is built on the Git GUI. What's the one that's built in, or relatively built in? A portable graphical interface to Git. Yeah, see also Git TK. The Git repository browser, yeah. So all of this stuff you can use to kind of get a similar thing. We can quickly sort of compare. So let's close that. Let's go to my one project I hack on is called Hedgehog, and I'm currently working through a Rust port. Everything is pretty much feature complete, but the problem is that it was ported from a functional programming language, Haskell and F#. And because of this sort of one-to-oneness with them, there are things that just don't quite work as nicely in Rust. Like, things are quite slow. I have to encode a lot of laziness into some of the data structures, and yeah, I'm going to go off on a tangent in this regard. But there are particular things that are slow because they need work. And maybe one day we'll also talk about that. But in the meantime, this project, so it's actually here. Git stash clear. Git. I have a lot of Git aliases. Git. So what's the command to make this work? Right usage. Do I have to download this? Hold on. Let's go back down. Git K. Sudo apt install Git K. Let's just download it for fun. So it opens something like this. Yeah, and it's a sort of something similar, but it's using GDK, or actually don't know if it's, yeah, I think it's GDK. So that's that one. So let's configure. So first we'll just run configure, right? And you'll kind of notice that the whole autoconf thing is that it goes through and it checks for files and pointers and stuff. And I mean, it checks for files and definitions for pointer sizes and, you know, other type sizes. You'll notice, like, where is it? Do we have readline.h? No, we don't. Do we have readline.h usability or presence? No. Do we have libz? No, no, no. Which is kind of interesting. I thought I did. Creating a makefile, creating SQLite 3.pc. So that's an interesting thing. That seems to be this small file that has a default prefix. It says package information for package config. Package config is FreeBSD's thing, I think. I'm actually really keen to give FreeBSD a go. Sorry, package config free desktop org. No, I think this is something else because free desktop is not FreeBSD. Yeah, this is something else. Description SQL database engine version 330. There are some libraries, and it's got libdir as a thing up here. Exact prefix, 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 prefix. Exact prefix is just prefix. C flags is the include directory. You also see that it made a config.h, and it made it did some libtool executions. So if we go config.h locally, you'll notice that it did all these things, right? So like define have malloc h1. Yes, we have malloc. Do we have a usable size? Do we have pread available? Yes, we do. Do we have a 64-bit pread? Yes. Blah, blah, blah. So the next step is make. And what make is going to do is it's going to actually build the project. So fun thing to kind of do with this is let's stop and let's watch it as it builds. See how labor intensive it is. And you actually notice that, unfortunately, the most labor intensive thing on this platform is you'll see 147% of my CPU is being used at OBS. CPU percentage load is not, we'll talk about it another day, but basically this is mapped to, yeah, we'll talk about it another day. It's not worth going down that rabbit hole. CPU load in Linux is a bit of a, well, Unix is a bit of a tricky thing to explain. It kind of is about the number of cores that are being fully loaded upon. And then just decays in the amount of time, like the window of time. I think that's it. I'd have to refresh my memory. So that's done. That was pretty quick. One thing I really want to do, so if you make this, there's nothing to make. It should have made a, I want everything that's a directory. I want everything, so this ext doc contrib compat autoconf art. So that, where did it actually install it to? So we can go back up and try to read through this. You'll notice that what it did was, well, here's a really simple way to tell, right? We don't need this up anymore. We want the generated makefile. So let's open up that in a new tab. And we want the all one. So what this is running is SQLite 3.h, SQLite 3.la, SQLite 3.txe, have TCL law, and it's going to run all these rules. Now these are rules or targets, right? So what this means is that it needs to have SQLite 3h available, it needs to have SQLite 3.la available, it needs to have SQLite 3.txe available, and we can go look at txe. Where's txe? Txe is empty, so it's not a extension, which I'm guessing would be specifically for like Windows, like it was like SQLite 3.exe. And then there's a thing here is that if we have TCL set to 1, then we're going to put lib TCL SQLite 3.la. Now I actually don't know what a lib SQLite 3.la thing is. Lib objects are required for lt link no undefined -o, allow release rpath lib directory. So let's go find that file. Okay, so np SQLite 3, this guy, lib SQLite 3.la, a libtool library file generated by ltmain.sh, GNU libtool. That doesn't help me. A generic library support script. So we can also go back up here and ask the question, libtool. GNU libtool, computer program. I love that. That's amazing. It's just a computer program. Let's close this and this. Don't really need this anymore. Although we can quickly take a look at this while we're waiting. Oh, let's just look at this. GNU libtool is a generic library support script. Libtool hides the complexity of using shared libraries behind a consistent portable interface. To use libtool, add the new generic library building commands to your makefile, makefile.in or makefile.am. That's auto tools. See the documentation for details. So different operating systems handle shared libraries in different ways, and some platforms do not use shared libraries at all. It can be difficult to make a software program portable. The C compiler differs from system to system. Certain library functions are missing on some systems. Header files may have different names. One way to handle this is to write conditional code with code blocks selected by means of preprocessor directives. But because of the wide variety of build environments, this approach quickly becomes unmanageable. The GNU build system is designed to address this problem more manageably. Libtool helps manage the creation of static and dynamic libraries on various Unix-like operating systems. Libtool accomplishes this by abstracting the library creation process, hiding differences between various systems. GNU libtool is designed to simplify the process of compiling a computer program on a new system by encapsulating both the platform-specific dependencies and the user interface in a single script. When porting a program to a new system, libtool is designed so that the porter need not read low-level documentation for the shared libraries to be built, rather just run a configure script or equivalent. Libtool is typically used with autoconf automake. I actually never knew about libtool until now. It is designed so as not to be dependent upon another. Okay, so libtool sets some stuff up for us. Version information. Don't really care about this stuff. Let's just hop back. Let's see here. Okay, so it required the build of all of this stuff, including the SQLite 3 file. I want to find all the things that are executable. Config status is executable. Configure, install, sure. Lemon script is executable, which we saw during the make. So actually, if we run make clean again, we'll figure that out. There's libtool. Libtool is that born again shell script. Okay, so let's go open that up. Libtool. Provide generalized blah blah blah. think this is automatically generated. Oops. Okay. Oops, my bad. Ah, right, we're not in a Git repository, so I can't do things like check the history, although that's kind of interesting, right? Like, how do I... Also, help. Oops. Okay. I don't really like... There's something funky. I used to have a keyboard shortcut set up so that I could quickly go up, arrow up, but I'm going to have to work around it. I just want to see if there's anything that's kind of like log. PQRS. I don't like that it's doing this column thing. So what I'm going to do is I'm going to do this. And then I'm going to type that, which one, there we go, into cut. Or how do I want to do this? I want to cut up these lines. Cool thing about Xargs is that if you run without any commands, it does this fantastic parsing thing with white space. And then all you have to do is type that into less. Oh, come on. But what do I want to do? I want to not type that into less. I want to tr anything that's a space into a new line. Yep, there you go. And then I want to take that and type it into less. So three-way merge, clean, help, reconstruct status. Actually, one more thing I want to do. I want to sort that guy. Dictionary sort. And control. And, oops. There you go. Three-way merge, add, remove, alerts, all, annotate. Bisect, blame, branch, cat, CGI exchanges, checkout, CI, clean, clone, close, commit, configuration, delete, deconstruct, diff, export, extras, gdiff, grep, hash policy, help, merge, new, publish, pull, push, rebuild, revert, very similar Git-y things. I haven't read that article yet. Surprisingly, there is a SQLite 3 command for fossil. I want to know what that does. Fossil help SQLite 3. Run the standalone SQLite 3 command line shell on database with shell ops. How interesting. So Fossil is used as the version control management for SQLite, but Fossil also relies or can rely on SQLite. I'm not sure about the use. The following extensions to usual SQLite commands are provided. Content compress, decompress, check-in, mtimes. So it's using some of this stuff as a wrapper around SQLite. In fact, I'd be surprised. I wouldn't be surprised if the whole fossils thing is just a big wrapper around SQLite. Because they can be bootstrapped on one another. So, I'm going to do the UI again. Close this one. Seems like latest is here in the top. Seems like master is just called trunk. Fix a problem with queries containing a min or max function for which the filter clause excludes all rows. Always clear the temporary register cache after coding a subroutine. Add extra tests for handling the corrupt records in FTS3. Fix another potential jump depends on uninitialized value warning. Fix an out of bounds read in the instr function introduced yesterday by check and blah. Let's go look at that one. Why doesn't it jump to it? But that's the fix the instr SQL function so that it makes a copy of its argument before changing the data type. Since the data type affects processing, also fix the SQLite 3 value text routine so that it always works even for values obtained from SQLite value dupe and detected by OSS fuzz, the text case in TH3. So this is something that's really cool. I'm a huge fan of property-based testing, but a tangential form of property-based testing, which is really about memory safety at its core, is called fuzzing. And sort of the same concept. Property-based testing is about coming up with these things called generators, and generators have values that are more about your domain. Whereas fuzzing is like just throw any random crap at it and see if it doesn't crash, right? And when it does crash, record it. And so a fuzzer will sit there and just fuzz a binary, right? It'll just throw random stuff at it, and every time it crashes, it records it and then it restarts it and it tries again with new different input. And it keeps track of what it did before so that it's not wasting time repeating again. Do not attempt the like optimization for non-text columns and a pattern prefix of dash. Add recent interesting cases from DB SQL fuzz. So it seems like this is also a ticket system built into it too. So that's kind of cool. So it's like a one-stop shop for SQLite. People working on the SQLite project, which is kind of neat. All these merges. Merge the latest changes from trunk into the Apple OS X branch. Merge recent trunk enhancements into the begin concurrent branch. Merge recent trunk enhancements into the begin concurrent PNU branch. Wall 2. A wall is a write-ahead log. Merge all recent trunk enhancements into the reuse schema branch. So there's a whole bunch of merges here that happen from this user named DRH. I don't know how you really tell between users. Yeah, interesting. Users. There's me, but there is no user on called DRH on my local system, so it doesn't matter. Fix a problem with processing, what's that called again? CTEs. CTEs are, let me see if I can remember. CTE. Common table expression, yeah. That use a window clause. One of these is interesting. I think it might be fun to check those out at one point, but nothing is really screaming at me, right? I kind of like this optimization one because I'm a bit of a maniac for that sort of thing. So this shows the diff, right? Where expression got updated. This thing was added, which was a ticket. It says if I2 is equal to 1 and Z new at 0 is equal to a dash, is num plus 1. Else. So basically, if the, what is that? Is 2, index 2 is equal to 1 and the Z new is 0, this, so we don't know what that is yet, but and it's got this little test in it, like3.test. Do exec SQL test like3 -5.420. Drop table if exists T naught. Create table T naught C naught unique. insert into T0 C0 values -1. Select star from T0 where T0.co glob dash star. So we're globbing this thing. I'm not sure what this syntax is. Maybe that's the expected value. Yeah, I think it expects -1. And then here do exec SQL test like 3-5.421. Select T0.C0 glob blah from T0 and then expect a 1 out of that after this happened. So these are stateful tests too, because you can see he had to drop this table if it existed, but then once he inserted stuff into it, is it stateful? Create table T0 C0 unique, and he inserted a -1 into it and expected a -1. I don't know if the table exists or not, but here he is expecting 1 if you get the C0 column off of it, where it has that thing. Weird. Okay. I'm not going to worry too much about that. We've mucked around enough. I think now really the core thing to do is to get into the flow of it. So there's two ways that we can do this. We can try to follow the description a bit about where their walkthrough is, and I kind of want to do that a little bit. The second thing is there are 3 primary ways to read code that I've sort of come across as patterns in my life, in my career. I've chronicled some of these in a blog post about a year ago. Let's see here. Reading review. Reading code is the pattern, yeah. This has a good laydown of it. I might go into further detail right now just because. So the first way is you treat it like a book. You treat the source code like a book, and you need to just go in there. You get pen and paper, and you just start recording things, right? So if you notice something odd, then you make a note of it, and you go, hey, why does this test need this weird block sort of looking thing? Or why is this thing looping across this array when it's not even using the result or not even doing anything to it, etc. Stuff like that can crop up, and sort of having a log of the questions that you'll ask will help you explore the sort of labyrinth that it is, because it generally isn't linear. The linearity of it comes out of a single place, which every program has, or library. Whether or not a library specifies a main, it still has an entry point, in my mind, I think conceptually. That entry point here is SQLite.c. In C, there are 2 types of files. There are header files, which specify the shape of data sometimes. They have specifications for the signatures of functions. You can technically put all that stuff into a C file and not use a header file, but it's generally best practice if you put it into a header file, because the point of a header file is that other things that want to use this library then only just need this simple file that specifies the interface. And the header file, whatever is in that header file, is going to be public. And whatever is not in a header file is private. It's kind of an old school way of specifying that. There is some documentation here. I'm not going to be too pedantic about going into this just yet, because I want to finish my sort of tirade on the 3 different ways of doing this. So that's puzzling over it, and that's very much like the Knuth way of doing things. In fact, many of these 3 ways that I've sort of come about, distilling into 3 different patterns, are really just taken from different people, primarily from a book called Coders at Work. And in Coders at Work, Peter Seibel, I hope I'm saying his last name right, he interviews, who does he interview? He interviews tons of people in the book. Knuth, Brad Fitzpatrick, you name it. And a lot of these people, he always tends to ask this one recurring question, which is how do you read code? It's an incredibly good question. And some people said that they read it like a book, you know, they read it from cover to cover, or they just go through it. Some people literally said that they would print it out and just kind of read over how things worked. Knuth was more of sort of a puzzling mathematics sort of take. So he was reading it, and he had a book where he would sort of record questions and discoveries. But the thing about Knuth was that he was sort of jumping around. He was really quite open to saying, what does this little chunk of code do, and what do I need to know from there? The different way that like Brad Fitzpatrick and a few others in the book sort of specify is the, what shall I call it? Make it run sort of approach in poke. Get it running and building, maybe even kind of running as a daemon or repeatedly executing some test or something, and just change stuff. Poke at it, see how it works. And this is now a really popular pattern. In fact, there's a bit of this frustration in the community because some people seem to say, the classic style of, think through it, reason about a program before you even touch anything, etc. is the way to go. Have all of your foundations solid and outright, really know what you're doing, be an expert. And the modern sort of approach is, that's not really the best for education, some people question. And they say the best way to do it is actually to poke and prod and see what changes, right? I like to call it toaster-driven programming, because it's a tinkering approach. And I find that over the years, I've learned a lot of foundations and I've done a lot of book smart stuff. But the tinkering approach is really powerful because you get feedback quickly about what's going on, and you can sort of quickly see, oh, well, if I add this test that sort of says what's going on over here, that it should do this. You can sort of test your assertions about a system with tests. You can sort of see that if I change this little bit of code, that was that maybe what we said before with the array thing, then actually it's a performance thing. Or maybe it's not so obvious, which is where the poking thing sort of falls apart. Sometimes the changes that you'll make, they're not quite clear, and you have to be a bit more curious and explore and maybe ask questions to both living people who have written the code, but also just see what the code does. In the end, if nothing happens truly on a myriad of different systems, then it might even be just dead code. The last approach, which is very similar to the poking approach, is the refactoring approach, which is making the code pretty. A lot of times, each of us has habits of how we write code. That might be with an automatic formatting tool, it might not be, but sometimes just turning off the automatic formatting tools that you have and just restructuring code so that it makes sense to you, and that's things like adding tons and tons of white space perhaps. So let's try to go down to where there's some kind of function. Right, so like here, right? And maybe this is like super unclear to me. And so I might start doing stuff like, oh, okay, this is my prelude. Maybe I'll add some temporary comments. I'll start renaming stuff, so it's like cursor, context, so that actually doesn't work. This is cursor, context. Stuff like that. I'm not saying that's necessarily what you'd have to do, but that's a bit of the idea that's going on here. So let's undo everything that I just did. We'll do sort of a combination. So one of the things that I think is kind of interesting that we'll kind of explore a bit now, and I don't know how long I've been recording, but we'll sort of explore a little bit and then we'll leave some for the next time. This walkthrough, we can close this one now about Git versus Fossil. This walkthrough is kind of nice because it is a walkthrough from the authors. It's them and their mental model of a system and how it works. Developing mental models of a system is a really important aspect to debugging, to coding, to even just using systems in general. If you know people who know the internals of Git know and are much more comfortable with using Git than those that have ever, that have just mostly kind of memorized commands. And I'm not using that as an argument for you to go off and learn Git, but I'm just saying that, like, if you have this understanding about Git, this sort of deeper understanding, then it's not the elephant and you're not pretending that the trunk is a tree or that the leg is a vase or something. You understand that it's an elephant and how to kind of look at it in the whole. What I'm trying to say here is that there are the author's mental models and then there may be ours. And I think I'm definitely going to be building up my own mental model as this goes along and see how much of that differs from theirs. This has a very interesting comment at the beginning, which says that this file is an amalgamation of separate C source files from SQLite version 3.30. By combining all the individual C code files into this single large file, the entire code can be compiled as a single translation unit. This allows many compilers to do optimizations that would not be possible if the files were compiled separately. Performance improvements of 5% or more commonly seen when SQLite is compiled as a single translation unit. This file is all you need to compile SQLite. To use SQLite in other programs, you need this file and the SQLite 3 header file that defines the programming interface to the SQLite library. If you do not have a SQLite 3 header file at hand, you will find a copy embedded within the text of this file. Search for begin file SQLite 3 to find the start of the embedded SQLite 3 header file. Additional code files may be needed if you want a wrapper to interface SQLite with your choice of programming language. The code for the SQLite 3 command line shell is also in a separate file. This file contains only code for the core SQLite library. And then it's interesting to me here that says, in place of a legal notice, here is the blessing. May you do good and not evil. May you find forgiveness for yourself and forgive others. May you share freely, never taking more than you give. This file implements routines used to report what compile time option SQLite was built with. Interesting. So, do we have a main file anywhere? Create a main function. And I'm actually going to use ripgrep a lot. I do use tags. Let's see about install. This is going to be kind of crucial. Okay, that's going to help a lot. Interesting. I used to use tags a fair amount, but I found that a lot of languages, the tags would be wrong, or there'd be multiples of them that would make it kind of confusing, hard to jump around. And then I discovered Silver Searcher through an old boss of mine. And then from that, I discovered ripgrep, and just that was the end of it, right? I just use ripgrep for absolutely everything now. It's very easy to quickly find stuff, because with a little bit of thought, you can figure out where you need to go. So we obviously have a main file somewhere. It's not going to be called function. It's going to be space main. Start of main program. Int main. And that's what we need to do here. Okay. Now, I also don't care about these tests yet. So what we're going to do is we're going to glob out everything that is not, that says test. Actually, that globs in everything that says test. So what we want to do is we want to put a little exclamation mark there. Cool. We have this extension stuff. We have autoconf. I think all I care about, we have a tags file showing. All I care about is source, really. let's love it. This guy. Nothing. Alright. Int name. Nothing in here. Okay. So let's maybe first start looking at the SQLite header file. That's really interesting. It says the author disclaims copyright. And this is the primary interface that people can use it. So technically, you could, you know, clone this or take the tarball or whatever as a local dependency, and you could write your program to your C program, Rust program, Go program, whatever, that FFIs out to C. As using this stuff. So let's just kind of have a look. SQLite in 64 type, SQLite omit floating point, SQLite 3 close, close v2, SQLite 3 callback, SQLite 3 exec, SQLite API. This is an interesting pragma thing. Define SQLite API. And it doesn't define it as anything. It's just an empty define. So that's interesting. SQLite extern const char SQLite 3 version. Int SQLite 3 version, lib version number. So this is the library version command, the source ID command, the lib version number. This is the compile options used. Getting a specific compile option, asking if a compile option is used, and you'll see that these are just defines, right? This is saying that compile option use always produce 0, which is interesting. Oh, if SQLite omit compile option diagnostics. So in order to get this, you have to actually, this just makes them idempotent, makes them do nothing. Right? This just returns a 0 casted to a void pointer, and this just returns a 0. Looks like a function that defines if it's thread safe. We're only 1% of the way into this. SQLite 3 close. SQLite 3 exec. Let's look at some of the notes on this. One-step query execution interface. This is a convenience wrapper around SQLite 3 prepare v2, SQLite 3 step. So this is interesting. You could probably, this runs 0 or more UTF-8 encoded semicolon separated SQL statements passed into its second argument in the context of the database connection passed in it as the first argument. If the callback function of the third argument to SQLite 3 exec is not null, then it is invoked for each result row coming out of the evaluated SQL statements. The fourth argument to SQLite 3 exec is relayed through to the first argument of each callback invocation. If the callback pointer to SQLite 3 exec is null, then no callback is ever invoked and the roles are ignored. Cool. So, and kind of reiterate some of that stuff here. An open database, SQL to be evaluated, callback function. So if you wanted to really just quickly execute some SQL command to SQLite with a database connection that has been opened, then you can do it with this API thing. A bunch of error diagnostic things, so beginning of error codes. Error, internal, perm, permission denied, abort, busy, lock, no mem, read-only interrupt, IO error, corrupt, some kind of disk IO error has occurred, the database disk image is malformed, can't find it, full, can't open, protocol, empty, schema, database schema change, too big, string or blob exceeds size limit. I wonder what that size limit is. do some tests. I don't really care about that. One kind of interesting thing you can do is you can say go. So you can hit G, Control, right, hard bracket, and it will show you all the places where it's defined. It's defined a couple of places, which one is this file, but there's also some under source. And what we were trying to see here is this one, case SQLite too big in T source. All right. Prepare seems like it would be, here you go, statement too long. So something can be too big if the statement was too long. So there's a limit for that. And if we quickly kind of hop over to that, prepare C. Prepare C. Number of bytes max len. Max len is DBA limit. SQLite limit SQL length. We can go this guy. So yeah. Array entries. That's interesting. If we dug a bit more, we could find out what the exact sizes are. I initially thought it was going to be something about the blob, and it probably is. There probably is something here. There's like a tokenization error where you're parsing and it's too big, which I think is what the prepare statement eventually gets. If the size of the dynamic string exceeds, might be returned at the size of a string or blob. Yeah, so you can see down somewhere. All this stuff, further result codes that are extended. Interesting that can't open dirty write ahead log is not used. Flags for file open operations. Ways to open SQLite. IO caps and locks, syncs. Here's some struct definitions. So a SQLite 3 file is really just internally a pointer to a struct of SQLite 3 IO methods. And I'm guessing that part of those methods, this is probably a virtual table that points out to, or like is maybe partially applied with the name or the location of the file. Let's see here. File control stuff. Here's a SQLite 3 mutex lock. SQLite 3 API routines, SQLite 3 VFS, which is the virtual file system, has all this particular stuff about, you know, p apt data, z name, syncter. No, is this, I think, are the names? Yeah. Max path name. Next registered virtual file system. What else is going on here? So yeah, there's a lot. This file is about 11,000 lines. We have some documentation with tables, which I'm curious about. Busy timeout, and then this one is get table. Interesting. So you'll see that in C, because we have to do manual memory management, a common pattern that sort of happened in the community is there's a bit of this like pseudo-ish object-oriented programming where you have callers that safely allocate a table and get it, and then a destructor, right? So this is like SQLite 3 table. And it's the responsibility of the caller to both get that memory, manipulate it, do a bunch of stuff to it, and then especially the responsibility of the caller to free it. And if a caller doesn't free something that isn't used anymore, which is garbage, that's considered a memory leak, right? So, convenience routines for running queries. We saw one before. So this is getting a table, bunch of different printf stuff, formatted string printing, mallocing via SQLite, and reallocating in SQLite, memory allocator statistics. So you can actually ask SQLite how much memory have we used. There's a high water command. That's interesting. I think that's something like a capacity. Let me just look in here. The memory high watermark is reset to the current value of SQLite 3 memory used if and only if the parameter to SQLite 3 memory high water is true. The value returned by SQLite 3 memory high water is the high water mark prior to the reset. The SQLite 3 memory used routine returns the number of bytes of memory currently outstanding, malloc but not freed. The SQLite 3 memory high water routine returns the maximum value of SQLite 3 memory used since the high water mark was last reset. The values returned by SQLite 3 memory used and include any overhead added by SQLite by its implementation of SQLite 3 malloc, but not overhead added by any underlying system library routines that SQLite 3 malloc may call. So it is the internal, so now we've learned that SQLite has its own memory allocator. It is writing its own malloc stuff. 64-bit malloc, a regular malloc, realloc, which is like you have a pointer that pointed to something that came off of the free chain of the malloc that we were watching, the memory that we were watching, and now you want to make that bigger, so I can do the, I being the allocator, can decide how to divvy that up. What else? And then we can also ask this question here, like size. All right. I'm trying to remember what M size is. Oh, it's a Windows thing. Returns the size of the memory block allocated in the heap. Gotcha. And what this Stack Overflow question is saying is there a way in C to find out the size of dynamically allocated memory, for example, after this? And some people are basically saying, no, you cannot. There is no standard or portable way. Some compilers provide non-standard extensions. If you were using something like kemalloc, jmalloc, emalloc, etc., those may or may not have ways of querying them. It has its own pseudo-random number generator, PRNG. It has authorizer thingy. Has a trace and a profile function. That's kind of cool. Tracing and profiling. These routines are deprecated. That's a bummer. Use the SQLite 3 trace v2 interface. Okay, so it's still there. It's just been superseded. A callback function registered by SQLite 3 traces invoked at various times. Trace statement, profile, row, and close. The SQLite 3 trace v2 interface registers a trace callback function x. Okay. That's the third argument. X callback unsigned void void void. Void star, sorry. Using property mask M and context pointer P. If the X callback is null or if the M mask is 0, then tracing is disabled. The M argument should be blah blah blah. The X callback is invoked whenever any of the events identified by mask M occur. Excuse me. The integer return value from the callback is currently ignored. So that's kind of cool. There's a tracing function. Query progress callbacks. What is this? That's kind of cool actually. Query progress callback basically would have the notion that you can run some callback as a query is being executed in the virtual machine. Opening a full database. So in SQLite, it's an embedded database. It lives on a file on disk. You open it, and then you can get tables out of it and query it, etc. And then you save it and you close it. So URI parameter, URI boolean, URI int64. Error codes, error messages, some error handling stuff. There is a structure called the SQLite 3 statement. There's a limit, runtime limits, gotcha. There are runtime limit categories, so it seems to be like length, SQL length. We saw that one before for the statement size. How many worker threads you can have. It's not 11, it's just saying that this is the number for the case. This is like an enum. SQLite prepare persistent normalized no v table. So the different preparations. It can expand the SQL. It can normalize it. You can call it explain. And this just says, is this an explain statement? Is the statement busy? There's a SQLite value, dynamically typed value object. SQLite uses the SQLite 3 value object to represent all values that can be stored in a database table. A SQLite 3 value object may either protected or unprotected. The terms protected and unprotected refer to whether or not mutex is held. The SQLite 3 value objects that are passed are parameters into the implementation of application-defined SQL functions are protected. Bind blob. What is binding? Binding values to prepared statements. In the SQL statement text input and its variants, literals may be placed by a parameter that matches one of the following templates. Okay. So I think when you put question marks, right, it's a way to avoid SQL injection attacks, right? And this is the binding that binds values that are passed in to the query to these things. There's a whole interface for that. You can get column counts, column names. I'm trying to be a bit fast here because we've been going on for a while. Database names, table names, origin names. Declared data type of a query result. So I'm assuming that the dynamically typed aspect of this is that stuff just kind of gets shoved in as a void pointer in that struct that we saw, that SQLite 3 value thing. And then this might return the type. Yeah, here we go. SQLite uses dynamic runtime typing. So just because a column is declared to contain a particular type does not mean that the data stored in that column is of the declared type, which is a pretty big thing when you discover that about SQLite. It's not as, say, rigorous as Postgres, and even Postgres has particular complications that occur. So SQLite is strongly typed, but the typing is dynamic, not static. What does that mean? A strongly typed programming language or type system means that you can't coerce values. A weak type system allows coercion. So C has weak types because you basically can have one integer type get promoted into a different integer type, or you can cast a float to an int, and since it implicitly happens, we call it weak. A strongly typed type system says because you can't, if you're going to coerce anything or any type of value or transmute it, you have to do it explicitly. Dynamic typing versus static typing is static typing happens at compilation time. It happens before the evaluation of the program, and dynamic typing happens as the program is running, right? Type is associated with individual values, not with the containers used to hold those values. So that's interesting. I'm guessing that that's part of the idea here, which is that this file is the declared type of the table column, right? So it's possible, I'm guessing, that with SQLite 3, we could store some string to an int table or whatever, and it would cast that possibly into an int, and then when we go to retrieve it, it might just go, here's this thing, here's this string, because that's what I think it is, and it'll just cast it back and be a string, right? Might be a bad example, but I think it's effectively that idea. Here's step. What does step do? It's evaluating a SQL statement. I'll read that later. There's data count. Fundamental data types. So SQLite supports integers, floats, blobs, null. It might support text if it's built with it. Otherwise, it does not. Right. So it always defines text, but it might have been defined with a different value here for these things. I'm reading this right now. Note that the SQLite text constant was also used in SQLite version 2 for a completely different meaning. Software that links against both SQLite version 2 and SQLite version 3 should use SQLite text, not SQLite text. SQLite 3 text. Yeah, there you go. So if this was specified, it upgrades it to this, right? And it ensures that both are there. So yeah, column blob, column double, column int. These functions are result values from my query. Column access functions. And if you look at these things, yeah, so the internal type is null, and then we request a type of integer, and the result is 0. So this is a table of the type of casting that occurs, right? We go float to blob, then it is cast to blob, cast to integer, etc. And we sort of saw that before with the declaration type idea. Here's a generic one, it's just column value. Here's the column number. Here's the statement to perform. Destroy a prepared statement object. So this is like finalize, and I'm guessing that frees the value of it. But it's unlike free in that you can call free on it multiple times, even if it's null. You can reset it, prepared statements, and create functions. So there are prepared statements like functions, stored functions. There's window functions that you can store. Text encodings. function flags. So this is for defining the prepared statements, the prepared things. So prepared statements in some databases is about this idea of having a function that you can call on whim. I'm not sure if prepared statement here means like I've gotten a query and I've turned that thing. That query consists of statements and I'm preparing the statements for the virtual machine. This says obtaining a virtual value. So it's like value blobs, etc. Value subtypes. This is a way of determining, given a value, what its subtypes are. Value duplication, value free, aggregate context, user data, context database handle. How far are we? 44% of the way in. I'm going to kind of rush to get through this. This has result value stuff, setting the result of a SQL function in case we need to change it. Collation is a it's like the locale of a table. It's like the cheap way I can explain it. Collation needed callbacks. So you can have a table in like Latin 1 and have another table in like UTF-8. Really, you should just have all your stuff in UTF-8. Suspend execution for a short time. So you can tell SQLite to sleep for a little while. Excuse me. You can so these are globals. This is a global string, which is the temp directory. This is a global string, which is the data directory. So these are being shared, and I'm guessing that since they're set at runtime at the start and probably maybe never being set again, it's intended to be thread safe, I guess, although it's not really thread safe to have a global pointer just hanging around, but go figure. SQLite 3 get auto commit, database handle, read only, determines if it's read only. Next statement, find the next prepared statement. So my guess is that from what we've seen so far, like what I said about prepared statements, it will prepare a bunch of statements and then it will step through each statement, executing them bit by bit. And this is a bit of the interface to the driving the virtual machine, I think, via SQLite 3. So you can kind of step through execution to the virtual machine indirectly, right, via SQLite 3 as the abstraction. Commit hook, rollback hook. So this is for like transactions. Update hook, so something to run on a hook. So that's when you say define a column and you say like on update, do this thing. And when that happens, it will call that hook. Enable the shared cache, release memory, the soft heap limits, table column metadata, loaded extensions. So there are extensions to SQLite 3. Auto extension, what is that? Automatically load statically linked extensions. Oh, okay. So here's some other structs. So we've got a SQLite 3 vtable. We have SQLite 3 index info, vtable cursor, and a SQLite 3 module. A module, I think, is all of this stuff. So this is a virtual table object. Next, end of file column, row ID, etc. So these are all functions that you can call off of a table. Index info seems to have constraints that might be applied to it, order bys that are on it. So this is like the default number of terms in the order by clause. Indexter, need to free indexter, order by consumed. SQLite index scan unique. Only one. Scan visits at most one row. create modules and drop modules. Here's that vtable we were talking about. It's got a module, a number of open cursors, so a number of references, and error messages from SQLite 3 and printf. It seems to just be, again, a single error message that probably is getting reused. Okay, so we're about halfway in now. We've seen a lot, and this has actually explained a really deep part of how this works, so it's been really kind of, at least for me, revelatory about how this stuff goes about. Blob close, blob bytes, blob read, blob write, VFS find, register. Let's see what else is in here. It has its own mutex implementation, which is pretty fascinating, although we'll see if it piggybacks on anything like POSIX. I imagine it's done a lot of this stuff with like malloc and mutex and etc. to enable cross-platform support easily. That's usually the large reason why you can do that. DB mutex, file control, test control, keyword count, str new, so create a new dynamic string object, finalize a new dynamic string, so it finishes this, can append to it, reset it, you can get an error code off of it or a length, the actual value from the end. So this must return a string, returns a proper string. So it's like a SQLite 3 str to an actual, C style str, C str. So SQLite 3 status, runtime status of the database, and these are some of the things you can ask status on. Malloc count, page size, cache. So if you have a running instance of SQLite, you can ask questions about this, like this. Look aside used, so this is the table or page stuff. Statement status. This is interesting. Status parameters for prepared statements. Full scan step, sort, auto index, VM step, prepare, run, mem used. So all of this stuff is probably used in the explain, I'm imagining. There's a page cache object, so we're getting into the paging stuff. This isn't bad because everything is getting dumped into a single file. And in fact, one thing I'll say that I learned from Julia Evans on a tweet probably 6+ months ago was where she was talking about, actually it might have been a blog post of hers. She was talking about doing some project and looking at some project like Envoy or Kubernetes or something. And what she did was she found everything that was, of a particular file type. And then she just catted them all together. And by doing that, she was able to quickly jump around and see what was going on, which I think is super cool. So there you go, right? And we can ask questions like SQLite 3 pcache method. Yep, and we can go find that now. Right, and there are those struct definitions. And we'll see that it's actually used here in the SQLite 3 config. So that's something we can do a bit more of next time. We'll get to the bottom of this and then we'll stop. So SQLite 3 backup, SQLite 3 unlock notify. What is this? Str I compare. It's an index compare. Str glob. Str like. Str SQLite 3 log. So this is their error logging interface. SQLite 3 write ahead log commit hook. This is used to register a callback that is invoked each time data is committed to a database in write ahead log mode. So auto checkpoints, types of checkpoints, vtable configs, vtab collation, statement, scan status, reset, cache flush, pre-update hook, system error no. Let's go SQLite 3 snapshot open, free, serialized, snapshot recover, no copy. Okay, we're at 80% of the file, and we're starting to get into some weird if-defs again. R-tree geometry callback. Register a geometry callback named zgeom that can be used as part of an R-tree geometry query as follow. I don't even know what an R-tree is. That's awesome. An R-tree is a data structure used for spatial access methods. How cool. For indexing multidimensional information such as geographical coordinates, rectangles, or polygons. The R-tree was proposed by Antonin Gutmann in 1984 and has found significant use in both theoretical and applied context. The common real-world uses for an R-tree might be to store spatial objects such as a restaurant location or the polygons that typical maps are made of, streets, buildings, outlines of lakes, coastlines, etc. And then find answers quickly to queries such as find all museums within 2 kilometers of my current location. So R-tree shapefiles is my question. I am familiar with these. The R-tree allows you to make very fast first pass and gives you a set of results that will also have false positives. Then you go over the set of candidates, fetching them from the shapefile by their index, and do a mathematically precise intersection test using Shapely. They're using PostGIS, which is I guess Postgres spatial mapping stuff. Cool. That's actually super awesome. I'm gonna have to read about that later. Okay, so let's go back down. So we can query our trees. We have these interesting little things here, which is like, is it within or not within or fully within, partly within. End of the extern C block if this is C++. That's disgusting. Sorry. Session object handle. Change set iterator handle. Creating, deleting sessions, enabling sessions, indirect sessions. What are we at? 82%. Awesome. Let's keep charging ahead. Session attach, table filter. Change set, diffing, patch sets is empty. Start v2. SQLite 3 change set next, change set op. SQLite 3 change set pk, old, new. FK conflicts, finalize. SQLite 3 change set invert. SQLite 3 change set concat. So what is what's this change set thing? Obtaining new values from a change set iterator. The p-iter argument passed to this function may either be an iterator passed to a conflict handler by SQLite 3 change set apply, or an iterator created by SQLite 3 change set start. In the latter case, the most recent call to SQLite 3 change set next must have returned a SQLite row. So my guess is SQLite change sets are about what you are going to change inside of the database, like a prepared statement. Create an iterator to traverse a change set. So this actually traverses the change set itself. So this v2 variant is still experimental. Assuming the change set blob was created by one of the SQLite 3 session change set, SQLite 3 change set concat, or SQLite 3 change set invert functions, all changes within the change set that apply to a single table are grouped together. This means that when an application iterates through a change set using an iterator created by this function, all changes that relate to a single table are visited consecutively. There is no chance that the iterator will visit a change that applies to table X, then one for table Y, and then later visit another one for table X. So what that means is, at least what I grok from this is that change sets are a way to sort of represent changes that are going to happen to a number of tables or a table and perform some optimizations around them. And we provide this iterator interface to make it easy to sort of introspect them and analyze what they're going to do. Perhaps for optimizations, perhaps for even just determining if they're valid. You can invert them. I don't even know what that means. Applying an inverted change set to a database reverses the effects of applying the uninverted changes. So each delete change is changed into an insert. Ah, okay, that's interesting. So it's a way to reverse what was done, or invert. Change group. Take a bunch of change sets and shove them into a group. Let's go. 91%, we're almost there. Rebaser, what's this? Rebasing change sets. Experimental. Suppose there is a site hosting a database in state S0, and that modifications are made that move the database to state S1, and a change set recorded the local change set. Then a change set based on S0 is received from another site, the remote change set, and applied to the database. The database is then in the state S1 plus remote, where the exact state depends on any conflict resolution decisions, omit or replace, made while applying remote rebasing. So this is kind of fascinating. And in fact, it is really fascinating to think about version control management as a database, because it kind of fundamentally is. I think that's a bit of the revelatory thing. It's like, wow, this whole idea of persistent management and having, snapshots of time is kind of like if you took a database, a traditional database that's very mutable, ephemeral is the term, and you can just change it to whatever you want. You wouldn't know what the history is. Whereas a version control management is about having multiple recorded, inspectable instances of a history. Although technically the idea with something like get or friends is that you can also alter that history if you want to, if you go out of the bounds. So that's sort of what this interface is similar to like a get rebase, I think, or a version control rebase. Okay, session configure. And here we are, 95%. There's this thing called FTS5 extension API. Interesting. Offered by an FTS version. What is an FTS? That's it. Not really sure what FTS5 is, but we can find out. Oops, sorry. Full text search 5. FTS5 is a SQLite virtual table module that provides a full text search functionality to database applications. Cool, so that makes sense. Yeah, that's remarkable. We got through everything in the main file, and this is, like the comment at the top said, this was a giant amalgam of all of the files, because that's faster, right, to compile. Yeah, sorry, go back up here. Amalgamation of many separate C source files. So that was pretty cool. I think next time we're gonna probably dig in a little bit deeper into some of the implementations, but we've had a good sort of top level analysis of what are some of the things that SQLite seems to offer. What are some of the sort of quirks about how SQLite might work? Like it's dynamically typed, one thing can be stored as one type and maybe retrieved as another. So that's something we might want to explore. Some of the other stuff is like, it having its own definitions for mutexes, its own definitions for malloc. And we'll also there was some stuff that we didn't really explore because it was quite opaque, which is more of the internals of the virtual machine, the internals of Lemon, the parser generator, the page cache mechanism, on and on. There's a lot of really kind of interesting little tidbits here. Yeah, so hopefully that was fun as well, and I'll see you next time.